Hey, hello everyone. Welcome to this session of Learn Live. Today we're going to talk about data science in Microsoft Fabric. That is a really nice subject. And well, let me introduce Nellie, who is works in the product team at Microsoft, who is creating all these experiences of data science. Hello, Nellie.
Hi, everyone. Really excited to be here and talk to you today about data science and Fabric. Thanks, Ismail.
Excellent. Let's start with the slides. Okay, so I was going to see the next slide. Sorry. Okay, so let's first discuss that. Sorry. Paul is our moderator in the chat. In case you have questions, please don't hesitate to ask there. He's going to help us with everything. And remember that this is an interactive experience. So the first thing that you have to do is go to this link if you want to follow along the modules and well, all the teachings today. Um, don't hesitate to participate also interactively. Well, we do these Learn Live sessions for this. We want you to be part of this discussion, learn with us, and share your questions, your doubts, your issues, because we know that it's hard sometimes to do these things alone. We struggle with issues and we don't have help. So that's why we do this. So don't hesitate. Okay, so this is the one of the last season episodes of the series. There is only one more episode next week, so don't stay tuned with the next one. And don't forget that we are running the Fabric Cloud Skills Challenge. If you complete all of these modules and share this with your friends, well, you can earn things at the end. So don't hesitate to continue. And also, this is a reminder, in this URL, you can learn how to activate Fabric if you haven't done so. It's useful, of course, to follow this Learn Live course, but also to start playing with all the other experiences, not only data science, but you want to try, for example, data warehousing. Well, this is the way to do it, or real-time analytics. If you go to the link, you will see all the details. So.
Yeah, so try Fabric, right?
Exactly. Okay, so, well, let's start
All
now.
right. Well, thank you, Ismail. And let's get started with this Learn Live session and the content that we're going to cover today. So today we're going to talk about, as mentioned, data science in Microsoft Fabric, right? And we're going to assume that you have, some sense by now about what Microsoft Fabric is. If not, there's a lot of materials there out there to read about just overall about Fabric. But we're going to focus on data science. And before we get started, we really wanted to cover, like what is our goal? What do we want you to take away from this session today? Well, first and foremost, we want you to have a great overall understanding of what you can do with data science capabilities in Microsoft Fabric. So we're going to start with trying to give you that overview of what you can do, for example. We're going to walk through how Fabric can help you to work through the entire data science lifecycle and the data science process and get you familiar with that data science process. So that's also one of our objectives. A big portion of this session is actually going to cover a walkthrough where Ismail's going to walk you through these notebooks and these steps in the data science workflows one by one, where you will have a chance to ask questions, where we're going to basically engage in creating a predictive model, training a machine learning model in notebooks in Fabric. We're going to use MLflow and some of those frameworks that are available to us in Microsoft Fabric to be able to track and track these iterations while we're building a predictive model. And then in the end, we're going to learn how to be able to serve predictive insights to Power BI in a very seamless way in Fabric. So these are our learning objectives. Please, this is an interactive session as mentioned. So use the chat, ask your questions. We want you to be able to go back to this walkthrough and be able to, complete data science tasks in Fabric on your own after this. So with that, let's get started and talk about an overview of data science in Microsoft Fabric. So many of you may ask yourselves, if you're not familiar with data science, like, hey, what is data science? How should I think about data science, right? So one way to think about data science is that it's actually a process of creating software, which is machine learning models are ultimately software that you create, but you create it from data. And you do it by extracting insights and patterns and knowledge from data sets. So that's ultimately one way. I know there could be other definitions there. It's just something that, but there's like, at least this is how I try to think about it. And sometimes you may ask yourselves, how does data science relate to data engineering and other practices? And it's important to also kind of think about when you're thinking about data science is that as you're ingesting your data maybe into Fabric, you're doing your ETL, you're loading data from multiple different sources, combining it, kind of cleaning and transforming the data, you are actually preparing your data ultimately for data science. So the work that data engineers do in an organization is crucial for data science to be able to happen. For example, if you're using the medallion architecture and kind of taking your data from that raw data through the bronze and silver and gold layers, ultimately, the more clean your data is and the better quality it has, the better you can apply data science to it. So of course, it builds upon the basis foundation of data engineering. And then of course you can do data exploration on top of this data that data engineers have put together. You can explore and analyze this data. And then data science ultimately is something you apply once you have a good understanding of your data, once you have a good understanding of what problems you would like to answer or questions you would like to answer, what problems you would like to solve with data science. And typically with data science, as we'll go through, there is a problem formulation. There is a question where you want to ask, how can I predict which of these transactions are going to be fraudulent or not? How can I be able to predict, if a given customer is going to churn or not, for example? Or, how can I forecast my sales? So these are just like some examples of problems that are very common, that are also common where you apply machine learning in data science. It's machine learning tools, basically, to apply data science. So I hope this was helpful to give you kind of that basic understanding. And if we jump into data science and Microsoft Fabric, right, there are multiple reasons and multiple things we're doing in the product to help you be successful with data science. One of the first things, obviously, we saw in that pyramid is that one of the first things you need to apply any form of data science is that you need data. And you need data to be able to have gone through the stages of data engineering where you kind of took it from that raw format and you kind of pre-process it to some level where you can continue to prep it for data science. So in Fabric, thanks to having one lake and thanks to having that easy access to data, we're actually making it very easy for you to apply data science and machine learning tools on top of that data, because the data is, you're going to see that in a bit when Ismail's going to show you that when you work in a notebook, the data is right there. You can interact with the data in one lake. You can store data in multiple different formats. And this is one way of saying that, hey, doing data science in the platform where all of your data engineering and ETL and data pipelines reside also gives you very good access to data. And you need data for data science. So I hope that that explains it. You also need good developer tools in order to do data science, because data science ultimately is a practice that where you're going to need to use or build your developer skills, right? Where you're going to need to be able to understand code, at least being able to read the code, understand certain concepts around software engineering as well. So having a good developer experience not only helps data engineers in Fabric, it also helps data scientists, because you're using Python, for example, to author a notebook code where you are training predictive models, right? And these things are important so that you have a good developer experience. For example, we have invested a lot in making our startup times really swift. So when I open up a notebook, I'm going to have a really quick startup time when I'm working with, for example, Python. You're going to be able to install libraries. And if you don't even want to work in a browser in Fabric, we also have added a Visual Studio Code integration. So you can start exploring and learning in a separate environment like Visual Studio Code, connecting to your Fabric workspaces. So these are all investments that we make because we know that being developer friendly is crucial for data science. We're also investing a lot in giving you the machine learning tools that you need, right? Whether you're new to data science or you're experienced, right? And you're watching this, we want to ensure you that in Fabric, we are providing you with some of the state-of-the-art machine learning libraries so that you can solve the problems that you need using the tools and the libraries that you need to solve those problems. For example, you're going to hear us talk a lot about MLflow. I'm going to explain a bit what MLflow is, but giving you kind of these state-of-the-art frameworks that are common even if you were to work outside of Fabric, so that the knowledge that you learn in Fabric and you can apply in Fabric is also something you can take elsewhere and apply, on other platforms. And it's just kind of the industry standard way of doing things. Just be aware of that as well, that you will have a rich set of ML tools in Fabric. And then last but not least, one of the beauties of Fabric, I think, and I'm a bit biased, I agree, is really that we're bringing data scientists and data science, right, into the same platform where you're doing your data engineering, where your BI analysts live, where your business domain experts live, where your data integrators live, right? And this actually promotes a lot of collaboration where you don't have to move data around and copy things around. Sharing is a lot easier, for example, in Fabric, and just a platform where you can all still, leverage access control and security to manage permissions, of course, but having these tools to be able to more easily share insights, more easily collaborate over the same problem. Because analytics is a team sport. Data science is very much a team sport. It's very rare that data scientists operate in isolation. You're going to need to work with data engineering teams. You're going to work with data analysts, maybe BI engineers. So keep that in mind as well, that there are benefits of having all of these team players kind of solving a problem together in the same platform. So that was the last takeaway of why data science in Fabric, basically. Now let's move on to talking about the data science process, because no matter what type of problem that you're solving, the data science process typically looks very similar in terms of what steps you go through to solve that problem. And you oftentimes start with a problem formulation. There's a question that you're asking. This question may actually come from your business, right? For example, if we take the forecasting problem and say, hey, we're looking at our sales numbers. We would like to have a predictive model that can better tell us, what the forecast is for our sales in the coming month, 6 months, year, right? And you start defining that problem, and then you start collaborating closely, looking at the data again. Data is at the heart of data science, right? And then moving on from the problem formulation more into, let me look at the data, let me understand the data, discover and explore my data, pre-process the data in many cases, before I can even start to build out a machine learning model or figure out what pre-processing to apply in order to build the best type of model that I can build, right? So there is a big part, and a lot of people, if you're familiar with data science, you probably know that you probably spend 80% of your time in this step, because a big part of data science is exploring and understanding the data. It actually takes most of the time when you're building a predictive model, and building the actual model, training the actual model. Once you know that you have the data in the shape and in the form that you need, once it has the quality that you need to ensure that you can build a predictive model, then the modeling piece actually is not the part that takes the longest, typically, right? And once you've done that, you can now engage in the modeling phase where you start experimenting in modeling. And data science is very much an experimental science, which means that you will not have the best model, and you will probably not be able to answer the question immediately with the first iteration of the model you build. It's an iterative process where you probably need to try out multiple different things before you can drive to the optimal set of combinations of parameters and other things to build that model, right? So that's why we talk a lot about, you're going to hear us talk about MLflow and experiments and models. And so that's an important thing too. It's an experimental science, which means that you're going to need to iterate on this quite a lot. So you see here that, for example, you prepare the data for the modeling, you do the modeling, you evaluate the results, you explore furthermore, and then you maybe go in circles here for a while to kind of figure out the best. But once you have derived to say that, I actually think I found a way to answer this question. I have a machine learning model that I think can do the job. Then you can continue into the next step, which is how do you now enrich new data that's coming in, apply the machine learning model, essentially take the data, send it into the machine learning model, which operates very much like a function, right? A machine learning model at that point can say, hey, give me some data, I'm going to give you my predictions, right? So that's essentially how it works. So you now want to take this machine learning model, you want to move from the experiment to the model, take the model and say, I want to operationalize this model. And as you have new data in Fabric, you can do this. I'm going to explain, what type of operationalizations we support. And then the output from this are the predictive insights. So the outputs from this model now are the predictive insights. And now you can serve those insights, to your applications or wherever you wanted them to be served to. And in Fabric, we're going to focus on how we do that best, serving them to Power BI, as explained. So I hope this gives you at least an overview of a very generic data science process. And the next step that I wanted to take was actually to say that, how does Fabric, concretely, how does Fabric help you with the data science process? How can I solve and answer these questions inside Microsoft Fabric? And that's what we're going to have, a long section of it once I'm done with some of these slides, where you can actually get more familiar with Fabric and what it looks like, what are the tools that you can use. But in this section, I wanted to get you familiar with some of the tools that you will be seeing Ismail demo in a bit. Right? So again, problem formulation, ideation, the fact that we're in the same platform as Power BI, because in Microsoft Fabric, you have Power BI, you have data science, data engineering, all of these workloads together, which means that you can actually take a look at your data in Power BI, and your business users and analysts probably already do. And you can take a look at that data and say, hey, you know what? These are the questions we want to answer, for example. And then you can get started to say, hey, well, now I want to take those questions and I want to answer them. I have the data now sitting in one lake, for example. You see here that we have data sitting in lake houses, where I can start that pre-processing steps. I can use notebooks, and this is another tool that you're going to be see in a bit, where we work with notebooks against data in a lake house. We're going to start exploring this data, you see here. And as I engage in the experimentation and modeling cycle here, the inner loop for machine learning, as it's also called, I can then start to leverage the different tools that we have in Fabric. For example, I can use the SynapseML library, but I can also use any third-party library or custom library that I want. And I can start building out the optimal machine learning model. And if I'm not super familiar with writing code, in Fabric, we want to make that still easy for you as users. So we are introducing low-code tools that can also, as part of the pre-processing step of this data, as you're cleaning out the data, you can leverage tools like Data Wrangler that is going to make it easier in a low-code way for you to clean up your data and then generate Python code for you. And this is going to be something that you'll see us do more and more, where we give you more and more low-code tools, because we do want to empower developers of any skill level, really, to be able to start getting familiar with machine learning and data science and data prep, for that matter. So Data Wrangler is another tool I want to call out that we're going to talk about. Next, you're going to also see us talk about, again, MLflow. MLflow has two different types of items in Fabric that we support: experiments and models. You're going to see those as well in action. And then we're going to take the models that we build, and we are going to apply predictions. We're going to run predictions on those models. And in Fabric, right now, in the current version, we support batch predictions, which means that if you have large batches of data, for example, they land in one lake, then land in your lake house, you're appending tons of rows, millions of rows to your tables, maybe in a nightly jobs. This means that that new data can now be enriched with these predictions on a regular basis. And you can use the Fabric tools like notebooks and pipelines to be able to schedule these things. But batch prediction is something we're going to talk about. And then, again, Fabric is one unified analytics platform. We have ways for you to be able to serve these predictive insights easily through one lake and direct lake, and make them visible and share them, for example, through Power BI reports. So this is the flow that we're going to cover today in this Learn session. And without further ado, let me just do a quick walkthrough of some of the experiences that you will see before we dive into the demo. So notebooks is obviously going to be a tool. As you see here in this animation, you see here that I have a notebook. I can work against my data in the lakehouse. And it's really a tool where we're trying to make it really easy, not only for authoring code, but also for documenting your findings. So in notebooks, you can visualize the data. You can even document sections where you just put images and text. It's really a great way for also sharing insights and kind of share it. If I were to say, I create a notebook, I share it with Ismail and say, hey, Ismail, do you want to take a look here? And I add all the context that he needs to read it, right? This is a super nice thing about notebooks. So not only do they help you to author the code, they actually help in terms of sharing knowledge and collaborating together. So that's one thing that we're going to take a look at. Another thing that we're going to look at, hold on, I'm just going to switch here, is a Data Wrangler, as I mentioned. We are adding tools inside our notebooks. You can launch tools like Data Wrangler that essentially help you to leverage Python, but you don't necessarily have to type any Python code. But given that that pre-processing step that we were talking about, if you remember in the data science lifecycle, that step takes probably 80% of your time. In Fabric, we're giving you Data Wrangler, which means that hopefully we can speed up that processing step, where you can kind of open up your data frames in a grid view. You can apply multiple different operations, and we take care of the generation of the Python code. And this is an excellent way to actually learn and get more familiar with Python if you're not an experienced Python user. So really recommend you looking into this, and we'll see this in action as well. All right, models and experiments. We're going to talk about this a lot. So models and experiments you're going to see are items that you can create in your workspace. So they're actually going to be items that you can open, that you can click on, you can explore. But remember that models and experiments ultimately are created for you to be able to keep track of various different iterations. So let's say I'm building an ML model and I want to figure out, say, well, I have 3 different options for how I could build this ML model. You can actually try out all the 3 different options. You can track those iterations through an experiment item in Fabric, and then you can actually engage in comparing those and try to evaluate which one is the best one and for what reason, for example. So that's what MLflow ultimately helps you with. So MLflow is a framework that gives you a structured way to track these iterations. And that's kind of what we call experiments. And then once you're happy with something, you can create a model out of it. And I actually created a visual here for you that we can kind of walk through, just to kind of show you a little bit what I mean. Because sometimes I discovered this myself, that initially it's like when I was learning about MLflow, it was a little bit, like confusing to say, hey, what is an experiment? What is a run? What is a model? What is a version? So let's go through that. So MLflow has, the 2 different item types that you can think of with MLflow are experiments and models, right? So if I create an experiment in Fabric, it purely means that it is a container of various different runs. So as I mentioned, if I'm building that forecasting model and I have 3 different ways of doing it, I can actually track those in 3 different runs. And then in the experiment item, I will get a chance to compare those runs. So it's very much an evaluation and comparison centric experience. And without MLflow, you can think of ways that I could do this. Well, I could probably create an Excel spreadsheet and I could try to log things in different columns. Like these are the parameters that I use. This is the type of model that I used. But tracking these things in Excel, which actually is something that data scientists have done in the past, right? Before MLflow, it's just very tedious, and you kind of lose track of what happened. You lose track of the lineage of the data and all of these things. So that is one of the advantages of MLflow, is that it gives you that structure and kind of makes it more enterprise grade. So you can truly keep track of all these iterations. You can even see that, for example, if the model that was created from run number 1 in the experiment was great, then I can actually say, I want to create a model item out of that because I want to operationalize that particular model. And that's when you create the MLflow model typically. So in a workspace, you may have many more experiments and runs than you have models. because model is usually something you create once you know that that's the one I want to go with. And similar to the experiment, the model type of item is actually a container in MLflow for multiple different model versions. So if I were to create, for example, if I have a model that I was creating in this iteration of run 1, and I want to go and create an actual model item out of that, what would be created in my workspace underneath my model would be a new version. So Ismail, I'm kind of counting on you to show these things in the Fabric workspace later. I know this is a lot of theory, so let me speed up and just stay tuned for those things. And what Ismail is also going to show you is how we can do batch scoring in Fabric. So this is something that you do in your notebook. Again, as I mentioned, think of a model as a function. So it takes a certain inputs and it has certain outputs. And in this case, depending on the model that we're going to take a look at later, what you do then is that you take a set of new data, you pass it into this function or model, and then you get outputs, which are the predictive insights. So we're also going to take a look at how you do that in batches in Fabric, what we call batch scoring. There are multiple types of scoring. We will support real-time scoring soon as well. It's on our roadmap, but today we support batch scoring in Fabric, just for your reference. And to make batch scoring easier, we've actually, again, invested in low-code experiences that can guide you on how to apply a model, like basically applying new data to a model and score or predict using a model in Fabric. So that's an experience that we have as well. Just for your, I want you to be aware of this. Again, we want to make it really easy for you to use machine learning tools. And these are the first steps we're taking to make this happen. And we're going to do a lot more going forward. So stay tuned for all of that. And with this, I think we're ready for actually seeing data science in Fabric in action. So I'll hand it off to you, Ismail, and let's walk through a real data science problem.
Okay, thank you, Nellie, and thanks for the introduction and all these concepts. It's a lot of concepts that we have to cover today, so we will see how it goes. If you are following along with the link of the course, well, this is what we have so far. I mean, Nellie just explained most of the concepts, so we are going to go straight to the exercise, which is here. And this will send you to another page where there are all the instructions of what you're going to do. So I won't go, for the notebooks part, I won't go with instructions. I'll just go on my own and we will discuss what is there. On the Power BI part, I will probably do because I don't remember. So first, well, the first thing we have to do is to create a workspace in Fabric. So the first time we open Fabric, we get something like this. Well, assuming it's the first time you are using it, probably you have an empty workspace like this one. And what we want to do first is create a workspace for this case. So we are going to go here. We're going to put a new name for this workspace. So let's call it Learn Data Science. Voila. Okay, so we are going to create this workspace. And this concept of workspace is fundamental in Fabric because it groups all your assets. So if you are going to create a set of notebooks, all of them are going to live here, your machine learning models, your experiments, all this information, you can find it in just one place. So now, something that you should see in the bottom of the window, bottom left, is this Power BI symbol. This Power BI symbol is the experience you are using at the moment. Since we are going to do data science, we can choose the data science experience, and we will have a series of predefined buttons and access to the things we want to do. So next, we have to import some notebooks. And these notebooks, if you were following here in the website, you will end up going to, I cannot find the link there, but you will end up arriving to this link, which is a GitHub repo who has 5 notebooks that you can download and import into Fabric. So that's what we're going to do now. Since we were here in the Fabric view, we are going to do now import notebook and upload the notebooks. I already downloaded them, so that just do not lose time on that. You take all of those in, and let's see how it goes. Of course, there will be moments where we will have to wait, so have to talk stuff because this happens, especially when we are going to train the model. These are CPU-intensive processes, so this takes a little bit of time. So Okay, so this was imported successfully. Now we can go to the workspace and we have our notebooks. So what we're going to do here is basically follow this machine learning lifecycle pace. So the first thing we are going to do is try to find some data. And well, before all of that, well, the question is what we are going to solve today. So what we're going to solve today is we're going to see this Azure Open Datasets website when we have lots of datasets that are ready to use. And we are going to pick one that is the New York Taxi yellow cab dataset. Just a short mention, Azure Open Datasets are a group of ready-to-use datasets that are part of Azure and that we can use from Fabric also. And these are already, let's say, you only pay what you use of these datasets. So we go to this New York Taxi. If you want to go into the details, this website has all of the details of the different schema of the dataset. No? But back to our Fabric environment, if you notice at the left side, sorry, you see this lake houses view. And at the moment, we don't have a lake house. So what is all about? So Fabric comes with this concept called One Lake. The idea is that we have a storage space where we are going to save all our data and everything we want to process. You can even save images and files or different types of files. And you can access those from all the different Fabric experiences. So if you want to use real-time analytics, you can access your data that is there. If you want to use the data warehouse style with SQL and all of this, also you can. So we are going to create a new lake house for this. So new lake house.
And Ismail, one thing that I always wonder is what type of data can people store in the lake house?
It's all kinds of data, no? It's in general you can put all sorts of files, but also, and this is first for Fabric, we prioritize this format called Delta Lake, and Delta Lake is a storage format that all of the different Fabric engines or experiences store their data in. And this is what we call classically a lake house format. And we, of course, we can also store classic formats like from big data, like Avro, Parquet, and others. No? So okay, so let's create this data lake. Let's create data lake. Okay, this is because I didn't call it One Lake. No, I'm kidding. So then One Lake, so we can remember that. Okay, so now we will have here this view with two components, tables and files. So if you can put files there, or you can put what we call tables that are in some cases are files that we read as tables. So let's go to the code. And the first thing we have, as I mentioned before, we are going to access this data set that is stored in Azure Open Datasets, and we are going to bring the data into our workspace. We could access the data directly if we want, but well, for the sake of this exercise, we are just going to import it just to see how we store data also from an outside part. And as you can see, well, I don't go ultra deep in the code, but what we are doing is reading this data that is stored in Parquet format in this storage component of Azure. And we are going to filter this data just to include the data of the year 2016 and the first 4 months of the year. So this is basically what this code does. And this is the first time we're going to run a notebook. If you are familiar with Jupyter Notebooks, it's the same kind of experience. If you are not, well, these are interactive tools where we just click, write code in cells, and we click and we interact and have answers or logs of what is going on. So let's start with this. And let's cross fingers now because now the demo effect starts. So we are, as you can see here, it's taking some seconds to start. And this is because in the backend, we're starting an Azure Spark pool of services. So this is quite fast. You see the message here that says Azure Spark session ready. It means that we already started a cluster behind the scenes, which you don't have to manage anything of this with Fabric manually. All is done. And all is part of your capacity that is included with Power BI, let's say, if you come from the Power BI side. Okay, so we have this data frame that is defined, this filter data frame with our data. And with this filter data frame, what we are going to do now is what we're going to write it in our One Lake. So to do this, well, there are two recommended settings that we have. One is this view order setting, which basically it's an optimization for future reads, especially from Power BI. So this comes from the traditional vertical optimizations from Power BI. And the second one is this delta optimized write. The idea here is that we want to produce less files, because sometimes these frameworks are created to be using massive amounts of data, and sometimes it creates massive amounts of files, and having many files sometimes makes things slow. So this tries to produce less files, let's say, during the write. So let's run this. And now we're going to save all this data in a table called taxi row. And I'm going to run this at the same time that I talk, so we went some time.
And one thing to call out there, I mean, of course, we're optimizing for the V order and those lines that you saw there, but they're also going to help us to be able to read data much faster from Power BI later.
Yeah.
So that's one of the key reasons we're doing this. So this is something that you can do in Fabric. You can just make it very swift through Power BI to be able to read this data over the lake directly, but we'll see that. I know I'm kind of jumping ahead here.
No, that's perfect. That's perfect, because I just mentioned Power BI, but I was not clear about this. This optimization is to optimize reads in the future. Okay, so now we are storing this, and notice that we are saving this in this delta format, that is the delta parquet format we mentioned before. This is an open specification, and this is something that is worth to mention. This is the first time that a Microsoft product is backed in a storage format that is open. So this guarantees that we have easy integrations with other systems. For example, if you are using at the same time that you use Fabric other tools like Databricks, for example, you can read this data also from there, or we can read the data that is there. So, okay, so this seems to be progressing, but not yet ready. We can, in the meantime, we can look a little bit at this. This is the Spark log execution. This shows if you are familiar with the Spark, you can take a look at the progress of your job. You can also check the logs, like this is really more scary, but you can see the logs for what all the things that are going on at the moment. Okay, so let's just wait a little bit. Hopefully we will see it soon. Basically, it should take like 2 minutes, so hopefully it will be soon. And I was just want to mention also something about Delta. I mean, because well, some people know we mentioned this Delta Parquet, both terms together. Well, Parquet is a storage format that is optimized for vertical reading, so for analytics, basically. Data is stored in a vertical fashion, so it's faster to read. Delta brings more powers to this data. With Delta, we can read, for example, multiple versions of our data. We can go back and forth in the future. We have time travel and many other features, so it's really nice. Okay, finally, we saved our data. We have the table here. We're going to see it appear here. We'll refresh. Yes, here it is. Our data was stored in this table. So now we're going to switch to the second notebook. So I go back to my workspace. Now go to second notebook. And one thing that you sometimes notice, and this is something that is that now we have still to associate our lakehouse for each notebook. So we are going to do that. We don't have to create a new one since we already created one before. It was this one lake. That's it. I had another one just in case of backup. If something breaks, I can still show you everything. Okay, so let's start with this. We are going now to read now we are going to read the data. And we are going to read we're going to read the data, and we are going to create a sample of the data. Why a sample of the data? Because it's too big first. So we are going to take 1% of the data and create from this a pandas data frame. So in all these notebooks experience for data science, we use data frames that are, let's say, it's not like when you write SQL. Here you can go interactively doing actions like, oh, show me this, clean this. It's more step by step. So we are, this also should take a little bit of time. Why we're using pandas, you may wonder, no? Because we were talking about Apache Spark before, and that the Spark is like the standard tool to do this stuff. Well, the other thing that is standard in Python, in the ecosystem of data science, is all the visualization libraries and machine learning libraries. So we have sometimes to jump between both of those. Sometimes we use pandas for some things, sometimes we use Spark for some other things. Okay, our data is there. So okay, so maybe, and this is probably a good moment to introduce Data Wrangler. So we check our data. So we are going to do this. Okay, so to do this,
Yeah, everyone, like, I love Data Wrangler. This is such an awesome tool. So I'm super excited about this part. Sorry.
Yeah. So, okay, so once we have this data frame loaded here, we can go to the data view and launch the Data Wrangler. It would find our data frame, this sample data frame that we have here. It's now here. And this will open the Data Wrangler experience. And the Data Wrangler experience it's a set of tools, let's say, that help us first understand our data. We're going to get familiar with the data. We're going to visualize some things in the data that are really important when we are doing these tasks of machine learning. Why is that really important? Because things like outliers sometimes change the results of these models. Or because missing values also are things that we don't care. So we take a look, we can see distributions of data quickly. We can notice, for example, it's loading. We can notice, for example, some strange things like the, for example, this is the total amount of cost of the taxi. Well, we don't see anything rare there, but we will see in a second. One thing also another important thing that we can do with Data Wrangler is to operate on this data. We are going to do data preparation tasks. So one thing we want to do, for example, is to remove unused columns. For example, I have these two that I notice that does not have values. And in the statistics here, it says that really is probably nothing that I care here about those two. So one way to remove those is to go to schema here. And from schema, we are going to say drop columns. And we are going to, oops. Oh, okay, session reconnected again. So now we're going to choose these two columns. And what is cool is that I can see a sort of preview of what's going to happen. You can see here in red that these columns are going to disappear. So, and if you notice here is the generated code of Python, and this is Python Pandas API. For the moment, Data Wrangler generates only Pandas code, but soon we will have Spark code as part of it. So we apply this. Now I have my preview that I don't have these two, if they disappear, for example. And one other thing that I want to check is this, for example, in this payment type, I noticed that one of these values is not really, that does not bring many significance because there's only less than 1% of the data. So I could filter that also. So I can go to this sort and filter operation, and we can choose filter. And I select the column, let's say payment type, and the condition that I want to do, and say like, okay, if this is not equal to, and then I can say 3, and then it generates the code here. You can see, look, the 3 appear, and then I can see the preview there, and I can apply this. And as you can notice, well, I already did 2 steps, but we have multiple steps that while we are cleaning our data. And once we have finished with all of this, we can go back and bring this code, the full code of all the steps that is here, back to our notebook just by clicking in this Add Code to Notebook button. So here we should have the code generated. A little bit higher. This creates a function called clean data that is called with our copy of our data, and then everything is cleaned up. But well, this was just to show you Data Wrangler for the sake of understanding the tool. But we are going to do these things following the current notebook. So I'm going to delete this cell. So now, once we start to interact with the data and get familiar with the data, what we are going to do also is visualize it. We want to visualize data to understand the patterns, the outliers, all the things that happen. So one thing as we do it is with the Seaborn library, that is a data visualization library. And okay, so
and Ismail, is there a way, like, because I think this is sometimes, I hear this question a lot around, like, how can I use other libraries, right? Because like for data science, sometimes, like, how does that work? Can you explain that a bit?
Yeah, of course. One thing is that, well, Fabric has already a set of libraries, and as Nelly mentioned at the beginning, all of these ready-to-use tools that are the standard in the data science world are ready to use. But sometimes we need to install a different library. It's as easy as just adding one library here. We can do something like pip install, is for those familiar with Python, and I can add the library. we can do it. For example, there is another visualization library called Bokeh. We can try to install this and see if it works, and we can import it and use it afterwards. One thing to notice also is that, well, we sometimes have libraries that we use for all of our notebooks, for example, in our companies. We can set up those for the whole environment, so we don't have to do this step by step. But well, for the sake of this example, you can just install the library like that, and then you will have it available. I can just try to see if it works. And well, if this doesn't work, it's because it failed. And as you can see, everything went smooth, so we can import the libraries. So yeah, so that's how we import new libraries. I'm going to remove just this to go back to the place where I was. Okay, so what are we trying to do in this experiment and in this data science prediction task? What we want to do is to forecast the duration of the taxi rides in New York. And it's probably a good time to maybe look again. I'm just going to go back a little bit to Data Wrangler just to see something. Oh, oops, I forgot it. I lost it. Wait a second. No, never mind. Well, we'll just go ahead. But what we're trying to predict is how long will the taxi trip last? How long we will take from going from one point to the other? And one thing we can visualize this is by creating. Oh, okay. No, we lost the session, so I'm going to go back here to run this. Sorry, it'll probably go faster. As I was saying, well, we're trying to infer from all these given parameters how long it will take a taxi run. So what are all these parameters that we have in the data set? We have things like, for example, the price that we pay. Price could be a really strong indicative of how long it is going to take. We have the distance. We have other information. I'm sorry, now I'm going back again to these steps. Okay, so now we are going to see if it works, this visualization. So all these visualizations that we are going to see help us find odd things with our data. So what we are trying to see here is just to visualize two things. One is the duration of the trip compared with the number of let's say, of taxi travels that we did. And one thing that you can see here is that if we see it in a normal scale, well, we don't see much difference. But so it's pretty common to use a logarithmic scale to see outliers and strange things. And as you can see, we have this small trip that lasts a lot of time. So maybe that's not good for the prediction model because it's a big outlier. Another thing we can do is to create bins to visualize the data better. So, for example, in which parts of how depending on how long is our ride, how many people did this. So, for example, it's obviously short rides are the most common, 10 minutes rides or less than half an hour, but probably it's strange to do more than 4 hours of taxi in New York. It's quite strange. So this is something we can see with this diagram. Okay, now we get to other thing. This is a different sort of diagram. This is a scatter plot where we're going to compare here are two things: the distance and the duration, and these different levels of hue is the number of passengers that were in this moment. It's here. Well, we don't see much information, but we can see one thing is that we have between 1 and 6 passengers taking the taxis. Okay, we can also see another distribution graph. This is a distribution of passenger count. And one thing that is curious here, well, again, we are seeing the same 6, so no surprises. Now we are going to create a box plot. This is a sort of graph, a more, let's say, elaborated graph that helps us to see how distributed is our data and how many outliers we have. The first one is not using. Sorry, the first one is including all of our data, but since we already had some outliers, for example, this trip duration that was too long before, and the point that I show above, well, we are going to get rid of those. So we remove the travels that did not have passengers, and we remove also the travels that took too long, no? So trips. So once we have this, we can see that our data is more homogeneous. So we say that that's something that we can consider doing with the data set. And now, well, this is another thing that we can, another graph that we can do. This is basically, we're going to compare the price with the fair amount with the duration of the trip. And we can notice something here, and that's interesting, is that, and also we can do it for the vendor. So from the payment type, for example, if you pay with credit card or cash or whatever, well, we can see the difference. We don't see like many strange things. We can see, for example, that there are less, let's say, of the type 3 payments. On the other hand, for the vendor IDs, we can notice something, and is that all of these outliers who have a lot of time come from this specific vendor 2, which can mean that this probably this information is not good. Probably this vendor maybe submitted the data wrong or something like that. So we can consider to get rid of that data. Of course, we are always trying to, let's say, massage and do all of sort of things so our data becomes useful for the model. No?
Yeah.
Then there is another.
Because
Yes.
just sorry to interrupt you there, but I think like because we're going through a lot of visualizations, right? A lot of these prep steps, and I feel like this kind of aligns with what we were talking about earlier. Just wanted to call that out, that the fact that you know a lot of the time you spend on just kind of like understanding the data, right? Really like finding those outliers and really getting the data, like at least extracting the set of the data that's going to be relevant for the ML training. I see like there's a lot of visualizations, all of that, and just kind of wanted to call out that this is what we meant with that 80% of the time kind of spending on this step
Yeah,
in the life cycle. Yeah.
exactly. No, you are absolutely right. This is somehow a hidden experience. Like some people assume that it's just called the model, that's it, but a lot of time goes into just preparing data so it's usable. And so far we had not even prepared it. We are just looking at it and just checking details of the data. And understanding, we have this the whole task of getting familiar with the data. So, for example, here we have a graph by hour, and we can notice, well, that early in the morning is when less taxis are taken, and it starts to peak around 16, and then it goes really up afterwards. So that's another one. And here, for example, we have a heat map also of the distribution. Oops, sorry, I have not clicked that. Oops, now we lost it. Okay, well, we had a heat map of the distribution of it was a similar graph, but with the distribution of different durations that for the trips of less than 3 hours. Okay, here it is back finally. So this is the hours of the day and the different days of the week, and you can notice, for example, things like, well, in the Thursday probably is the day when people take more taxis. It's because Thursday is the new Friday, but maybe I don't know. Okay, so now we're going to see also, and this is a really interesting graph, a correlation plot. And this correlation plot, what it shows is how one variable and the other are related. So for example, if we see this trip distance and this, and the fair amount, so how much we paid for the distance, this is strongly related. This is important information for us. So that's something we may care about. But for example, if we see trip distance and day of the week, well, it probably is not really significant as a relation. So this is the kind of information we can get from these graphs. So, okay, so all of these, well, we can have a summary of some of the observations we did. For example, well, passenger count 0, well, probably it's not really important. Most of the trips were between 1 and 6. We have also trips that are longer than 3 hours are probably too long, so for consideration. We have outliers with vendor ID too. So now we have to clean all this data, and that's what we will do in the next notebook. So let's go to notebook 3.
And basically these notebooks, right, if you correct me if I'm wrong, Ismail, but these notebooks are exactly the notebooks that our audience are going to be able to walk through.
Yeah.
They open up 1, 2, perfect.
They are following along. If they are following along, they will be able to do exactly the same thing. So, okay, so now we are here. We associated our lakehouse again. And now we're going well, same story. Now we're going to read our data from the data lake. This raw data, we're going to transform it to let it clean and prepared for the machine learning model training that is coming afterwards. So we are going to read this. Okay. And well, this will take a little bit. Okay, it happened. Okay, so now we are going to see the statistics of the model. Let's say it shows for each of the variables what are the max, the minimum, the deviation, similar things to what we could see visually with Data Wrangler. Now we have it with concrete numbers, let's say. So that's another thing we can see. And now with this information, well, we are going to do some things. We are going to add extra columns, and this is the real data prep part. This is when we are going to expand and create more columns. For example, in here we are going to do some things. Let me just move this a little bit so it's more clear. Maybe I know this looks a little bit intimidating, but don't be intimidated. It's just fixing, adding extra columns and cleaning some ones, casting types. So we have, for example, the pickup date. We are going that is currently a string and it has a really odd name. So we are going to put it a nicer name and we are going to cast it as a date. We have the week of the day and we do a conversion from the full timestamp into this day of the week. Or also we are going to put the name of the day, which day of the month. We are going to do the pickup hours, and of course, we calculate the trip duration. That is our main objective value, or that's what we want to predict. And we are going to create time beans, let's say, for different times of the day. There's like, let's say, buckets of hours together, like the morning, the afternoon, the evening, and the night. And of course, what we saw at the end of the previous slide, we're going to clean up some stuff. We're going to remove the, for example, negative values from the cost. We are going to also negative distances and all of the sorts of data. So let's run this. Oops, I should have run this before because it's okay. That's important, interesting. You can notice that it took only 1 second. You say, oh, how did I transform all this data in 1 second? Well, no, it's not so fast. Actually, is that this framework, and I'm talking about the Spark, uses a lot of lazy computation. So data is not computed until it's really needed, and it's only needed here when I'm going to write it. I just did click in advance, so we get a little bit of time. So there's something to keep in mind. This is how Spark works. It has two kind of operations: these transformation operations and really creating a graph of tasks that we are going to execute. And once we really run this data, or we write it somewhere, is when they are really executed. And this is what's happening now. So again, we're going to take some time. For essentially like 2 minutes until we create this prepared data table. And pandas is different because in pandas with most of the time the APIs execute immediately. So that's probably one small difference between the two. Let's see. Okay, similar story. I can follow what the progress here with the Spark. And okay, so now we have a little wording around. Yeah, you can see, for example, here is mentioning this skew concept that could be intimidating at the beginning if you see. But basically, the idea is that it's analyzing why some tasks are taking long. Let's remember that this is running behind the scenes in different machines and is distributed. So sometimes one task can take more than one task, or some data can take more time to be read than the others. Oh, okay, what's going on here? I hope I don't have to write this, execute this twice, and probably it's going to be the case. Let's wait a little bit to see if this finishes.
Yeah. And one thing also to call out here is that one of the advantages of using Delta, where you kind of like, let's say you clean up your data, you do preparation steps, and then you save it down to a Delta table, which is actually a great thing, because if you then apply your machine learning on top of that table, then you can also always go back to a specific version of the data set, which is valuable, right? Because like for data science, sometimes, in certain industries, you also have to, for compliance reasons, you have to be able to go back and reproduce the same results. And for machine learning, that's also another thing where for being able to reproduce the same results, building the same model on top of the exact same data, it could be important. So that's actually something to call out, where Delta actually helps us a lot, because it offers these time travel capabilities, and it means also that we can version the data set that we'll actually use for the ML training. Just wanted to call that out.
Okay, excellent. It was a false alarm, let's say. It just was able to write the data, so we don't have to run this
Perfect.
twice.
Yeah. So we
So let's
refresh
do,
the lake house there.
yeah, perfect. So we have the data here the generated data. Okay, so now we're going to pass to the second most important part. After cleaning the data, doing all of this stuff, we are going to run and train our machine learning models. So this is the next notebook. So let me just close a little bit those two. And let's go to this one. Okay, so number 4. Again, same story. We're going to associate our lake house, learn one lake, duck. And now it's time to talk a little bit about MLflow. So I would be glad with any extra explanation from your part, Nellie, since you are the MLflow expert here.
No, I mean, just to kind of like, hey, MLflow, like if you are already experienced, I did ask the audience in the chat, by the way, Ismail, I was like, hey, how much experience do you have? So for those who are experienced with data science, you probably have heard about MLflow. But again, completely understand if many pro data scientists don't even necessarily use MLflow, right? It's more of a tool that, again, helps you track. And the fact that you can use the standard MLflow APIs means that you're not locked into Fabric when it comes to model and experiment tracking. Like if you're using MLflow elsewhere, you can easily migrate those notebooks in and run them. If you want to move your notebooks from Fabric and run them elsewhere where you're using MLflow, you can do that too. So there's really value in standardizing, we believe, right? And this is the closest thing to a standard out there, right? There is really no standard for how you track ML models and experiments, but MLflow is very close to that.
Yeah.
So, love MLflow.
Okay, so let's start. So, okay, the idea in MLflow, as Nelly also mentioned before, is that we are going to have a formal way to storage our experimentation. No? We are not tracking this through Excel files or notes or whatever. We are going to have this framework who allows us to create experiments and remember the parameters we run the experiments with, and even the whole configuration of our environment, so we can reproduce the experiments, because that's the hardest part in machine learning sometimes. Like, yeah, it works in my machine, it's a big symbol in machine symptom of not doing machine learning well. So this is a way to avoid these issues. So the first thing we do now is just to create an experiment where we are going to track and register our model with MLflow. So we're just basically giving it a name. Well, this takes a little bit to start the session. And then what we're going to do is we're going to read the data, just the next step. So, okay, so it started to create the experiment. Okay. Now we are going to just read the data, and we are not going to read all the data. We're going to read half of the data, just because it will be faster. And then from this half of the data, we are going to do something that is classical in this kind of inference task in machine learning. We are going to break it into parts. One part is our data that we are going to use to train the model, and one part is the part we are going to use to test the model. So this is 75% of one, 25% of the other. And this also will take some time. And also we are going to select some of our features. Our features, let's say, is for those who are familiar with just tables, let's say that start like our columns. This is the kind of information we are going to use to be able to infer things through our machine learning model. So here we can see we have categorical features that basically are like enums, let's say. So this kind of values where we know the values for each of these. For example, we saw before that we have payment type. We have 4 types of payment type. We saw also that we have vendor IDs. We have 3 different types of vendor IDs. But we also have numerical values or numerical features, like the number of passengers who were in the taxi, or the distance that we did to go from one point to the other. So, okay, this should take a little bit also. And also one thing that notice is that here we are using this cache. This cache allows us to materialize the data, so the computations are faster. If we have a really, really, really big amount of data, well, we don't have the luxury of being able to do this cache, but for this example, it's quite useful. So let's wait a little bit. This also again takes probably like 2 minutes.
Yeah, and another thing to call out here is actually that we have introduced auto logging for MLflow. So even if you're not like super familiar with MLflow itself, yeah, leveraging auto logging, we will actually take care of the logging for you. MLflow has this as a feature. So for certain notebooks, if you're running, let's say, a scikit-learn training pipeline, we can actually automatically capture these metrics. So you don't even have to type any MLflow code. it's automatically going to be captured. It's a setting on the workspace level. Just wanted to call that out there. So if you don't want to type MLflow and all this tracking code every time, there are ways that you can get that for free.
Yeah, and well, in this notebook it is not the case, but we could have done it that way. That's for sure.
Yeah, we could actually have done that way, actually. But again, we want to talk about MLflow, so that's the reason.
Yeah, exactly. And also, just for conceptual knowledge, when we talk about logging, what we are saying is storing all the information related to our run. So we are going to store what were our inputs, let's say our columns, our inputs, our outputs. We're going to store which model we were using, the initial hyperparameters that the model has. All of this stuff is what we log. So, okay, so we have now the data separated in two. And now we're going to create, and it's time to talk quickly about something, this library that is called SynapseML, that is what we use in one of the main libraries we use in Fabric to create machine learning tasks. And SynapseML integrates different frameworks. It can integrate another framework called IGBM, that is a framework to do inference tasks also from Microsoft. So, but again, as Nellie said, this does not have to be the Microsoft approved tools. We are using this because, well, we are familiar with those and they are well integrated also. So here we're defining our inference regressor model. So I won't go really deep into the details, just run this and explain quickly. This is a pipeline of 4 steps. So we have one step where we're going to index the strings, we do one hot encoder, then we convert all things to vectors, because in the end what we are going inside is having as width, and finally we apply the regression function, which is reading these parameters into. Okay, so now about these parameters, well, all of these different machine learning algorithms use parameters by default. Let's say we are going to assume those as they are. We define those here. And then we are going to do our actual run. So for our run, we check if there is an active run. Otherwise, we run this pipeline, and we try to fit it with our data. This is the key part. We are creating the model. And we also are going to create the predictions with that. So let's run this. This also should take some time, like probably 1 or 2 minutes. This is going to be a little bit long. And I can just, okay, the next thing we are going to do, let's say, in the following step, while this is running, is to compute the model statistics. Once we put this model with all the data and all this configuration of the algorithm we're running, we want to see if it was good or no. So to do this, we get something out that we call metrics. And this is what we compute in the following step. But let me see if this advances. It's probably going to take more time. And before we go there. Okay, maybe what else can I mention about MLflow here? We didn't check this. There is this start run keyword. Basically, what we are, as Nellie showed in the slides, we have this concept of an experiment who can have multiple runs. So we are doing one of the runs of this experiment. And obviously, well, once we finish the run, we can do this end run command. That's going to probably happen in some steps. Just a second. Wait a little bit. Okay, here we are. Well, this is a moment also to remember that, well, most of these machine learning algorithms took a lot of time to train, so this is not, let's say, hopefully it's not an outlier, is what it is now. Okay, we're almost there. Okay, there we are. So we have this run ID that basically is our identifier for the run we are into. This is just a hash that is created with this information, an ID. Now, as I said, we run this to get the statistics of our run. It's nothing. And each algorithm has different, let's say, metrics we use to measure if it's good or no. So this, we would love to go into the details also of this, but well, it would be a full session just to talk about how we train and evaluate this model. So for the moment, we are going just to take it as it is. I wonder if this is running. Just a second. This was not finished. Oh, sorry, I thought it was already finished. No, it's still running the previous step, and I was already down. So now we're in a queue. Should be pretty soon. It's like 2-3 minutes normally. Yes, finally. Oh no, still ongoing. Okay, this is classical. Okay, finally, the prediction was run. That was the last step. As you can see, now we have all the predictions were done. The first part was the training. Now it's this small prediction, and now we got these statistics that were calculated from the model, and we use those to evaluate and see if we continue iterating, for example, changing our data or changing the hyperparameters during training. So now we go back and we're going to register this with MLflow. I'm going to run this and explain it at the same time. So we define this function to register our model, and this receives several parameters. We receive the run that we are into, the model we trained, the name of the model, and things like the signature. And you might wonder, what is the signature? The model signature is just the inputs and the outputs. So all these features, all these columns, let's say somehow, and the output that we have is, well, our inferred trip duration. That is what we want to be able to infer from the other parameters. And also, well, you can see that we have this log specific task. We have log model, where we log the model we're running. We log the parameters, the hyperparameters that we use to run the model. And we even log the metrics that we got out as a run. Why? Because we want to track this in time and probably choose which one was the best model we executed. So well, that's for this. And with all of this, we should have this model URI. Now we are going to do a second run. What we are going to do is just simply change a little bit the hyperparameters to see if we got something else. Oops. This is exactly the same code than above. We're just changing the hyperparameters, and we are changing something else. I forgot. We are removing this payment type variable because this probably has not a lot of impact to the training of the model. So this is this. And again, we're also going to calculate the metrics, the statistics of the model. This is ongoing. So again, we have to wait probably 2 or 3 minutes to do that. Okay.
And one of the things that you're going to see coming forward, like I think it hasn't, been released just yet, but very soon, is actually that you can see a lot more information inside the notebook on models and experiments. So as you create the run, you're going to see more details in the notebook. So you don't always have to switch between, it's easy to switch between the experiment item and the notebook item, but it's still kind of work, right, to click back and forth. So you're going to see a lot more in line, basically, in the notebook output. So we're doing a lot of these like smaller improvements to make that easier for you.
Yeah, something I wanted also to show, and I was thinking is that, well, we can see also the progress of this since we already created this experiment, we can see this experiment in the UI of Fabric. So that's something we are going to check at the moment. So and you can see, well, this is still ongoing, but we have the first one that we already run. Mm-hmm. So we can have all these metrics that we calculate, they are stored there. All the parameters we pass to the regression model are there, the input schema and the output schema. All these things that I called the signature before, all of these are logged now and we have it there. And well, this one is ongoing, this is running, just to show you that at the same time we can evaluate other.
And those are randomly generated names, by the way, for those experiments. So if you don't want to call it amusing stick or whatever it was called, or tidy bulb, you can actually rename them.
Yeah, of course.
And those are it's just a way for you to quickly be able to remember them.
Yeah, that reminds me a little bit like with the Docker images. There are more and more things that are using this kind of auto-naming stuff. Okay, so this is still ongoing. Let's see if there is something else I can show before. Check. Oops. And we can also see the model, no? So far we look at the experiment, but we also can see the model that we calculate with similar data. So this is the first version of our model. And that's one thing that is really interesting, is that we can save different versions. Every run of these are saved, but especially the configuration that we use is saved. So if you want to use this, you can see all the Python dependencies that were used to do this run. So it's quite useful. You can see them in conda format or also in pip requirement format. Okay.
And one thing you'll actually be able to do, we don't have that yet. We have a long list of things we're working on, is you can actually rerun. One of the things we want to do is that, like when you go into the experiment run, for example, our goal is that you just kind of click rerun, and we would just rerun that notebook for you with the exact set of data and everything that you use with the same set of environments. So that's something that you will have eventually, be able to reproduce every run kind of seamlessly just by clicking it on the run.
Yeah. Okay, we are done with the prediction. That was great. Now we have the other results. What we would normally do here is just compare these values with the other and see which one of the two models is the best and choose it. So this, for the moment, we just assume that this is the good one, the second run. And now we are going to register this and running, sorry, this model and register everything in MLflow. So now we're going to the last step. Probably should be a little bit longer. And there we are. This is ongoing. Okay, perfect. So we have now this URI from our model. Let's gonna run this. So we have to save this URI because we are going to use this in the next notebook. Sorry, I'm going just to paste this somewhere else so I don't miss it. I'm gonna copy it twice because I'm not sure. Okay, so now we are going back to the notebooks. Now this is the oops, we're a little bit late. Okay, so this is our fifth notebook. Okay, so now we are familiar with this. This is the Spark configuration we had. Oops, forget to choose the lakehouse. Now we're going to run this, and we are going to now read. What we are going to do in this last notebook is we are going to read the real data, and we are going to pass it through our model to see if the generated values for the duration of the trip. So, and then we are going to compare both of those to see how close or far we are from the real data that we have. So now we have this, we are going to read the data. And again, we are also sampling the data, taking a smaller amount of the data, only 1%, for the sake of being short. And we are going to load this model from, where is this? Okay, so here is what I forgot. I had to copy the URI. So this is the URI that corresponds to the model that we trained in the previous step. So now we have the URI. And now we are going to read this model that was there. Let's see if all goes smooth. We should have the model there. And then we are going to run this model to predict our data. We remove some columns that are not used. And we are going to create a new column that is going to be called predicted trip duration. So we can compare the trip duration that the original and the one that the model predicts. And then we're going to save all this data into a table. This is another step that can take a little bit of time. We are going to save this data so we can compare it further. And also, well, because ideally we're going to check it with Power BI. And once, okay, this will take a little bit. Okay, things are moving. Okay, so the output predictions were saved in this new table that is called predictions. Probably will see it here now. And well, notice also that we can use SQL from inside the notebook to check this data. You can just run this magic command. This is called a magic in the notebook's parlance, let's say. And with this, we do just run a query on this prediction table, and we are going to limit just to see the first 20 results. So hopefully, okay, they are. There we are. Okay, so now we can see that we have at the end this predicted trip duration column, and this is the trip duration that was originally in the dataset. As you can see, for some cases where we have significant differences, for other we are really close by. So like this one, for example. So this is what we did here is what Nellie before called batch scoring the data. So we run all these things on a batch set of the data on a little group. We run all of these prediction tasks. So okay, so that's for the notebooks. Now we are going to go to the Power BI part. Just to remember here, we were doing this. Sorry, this was. Now I'm lost. Give me a second. I found my way into all these windows. No, yeah, it's here. Dun, 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 I'm lost now. No, this is not the. Okay. Give me just a second. Sorry, I cannot find. We are exercise, launch exercise. Oop, that was odd. I can't find the Power BI part. Oh, give me a second. Because this is different from what it was before. Okay, let me. No, just give me a second. Okay, here is the Windows. Sorry for that. I lost that part. Now we have the Power BI part. So this is the sixth part. So what we're going to do now is we're going to use Power BI to basically visualize the difference between our predicted data and the original data. So we're going to be switching a little bit back and forth between Power BI and our Fabric session. So first thing is that we are going to go to this One Lake data hub, and there, sorry, we are going to choose our Learn One Lake, and we are going to try to open this lake house from. Oh, oops, sorry, that was my mistake. Trying to do it by. Just give me a second. I'm going to follow the instructions better because I'm inventing. Sorry that I'm switching so fast. Okay, no, so there's none. I was correct. Sorry. We opened this lake house, and now we're going to create a new Power BI data set. So you notice this is the same workspace where we were before. We are in the same One Lake that we created. And notice also that you have an SQL endpoint that you can use from Power BI. So we are going to create a new Power BI dataset, and this dataset is for our prediction table. So we choose the prediction table here. Check. Oops, we have 7 minutes, so hopefully this go faster.
Yeah, this is the best part though. So like the fact that it's so easy, I feel like this is one of the reasons I think like iterating between data science and presenting your results in Power BI is a powerful tool.
Yeah.
To talk to stakeholders. Yeah.
Okay, so we are going to create a new report, and this is probably the moment to talk about what we call direct lake mode. And it's the idea that you can use your data you can create reports from the place where your data is. Usually in Power BI, you have to import the data, and then you can do stuff. Here we can go straight to the source and create our reports. So, okay, so now we're going to create a visualization. We are going to start with this. What is this thing? Interesting. A slicer. This is this thing. Okay, so we're going to create a slicer, and here we have our data. Okay, and what we are going to put in the slicer is the pickup date. Sorry if I switch a little bit fast, but we're a little bit sorry. Yes, this one. Oh no, it was not the right place. It was in field. Sorry, definitely not a Power BI expert.
We could have used the Power BI Copilot right now, I feel like.
Yes, definitely.
Yeah, and it's coming. So like just as a, like I feel like overall, honestly, Copilot's going to accelerate a lot of these experiences, even if you're not familiar. Like
Which
I
is
myself, I'm not super familiar with Power BI, but I'm sure the people in the audience are probably just laughing at us right now. But the fact that you can use Copilot, and also I like to use the auto generate at least to get to the baseline, and then I can start editing the charts and the visuals.
exactly. Okay, so we are going here. We're going to add the time beans, oops, into the x-axis, and we are going to compare our data, so our predicted and duration and our normal duration in the y-axis. And this is the predicted one. And well, we are going to compare just the average of those, not the full deal. And as you can see here, well, I'm going to make this bigger. They are quite close. So we're binning the data, we're comparing in the afternoon, the morning, how far is the predicted values, the average predicted value one from the other, which is a really good indication that our models is doing a good job. Okay, so now we are going to do another comparison. We are going to create this one. Check. And now we put in here weekday name and the average. Okay. So we put this weekday name here, the duration here, and predicted the duration in this axis. And again, similar. Oops. Sorry, it was not the sum, it's the average. I forgot. What we're going to compare. And you can see, well, here you can see a little bit of difference, but well, it's not significant. Well, we can also add other things, but well, I think we should stop there because we only have 3 minutes, so it's probably a good idea to stop there. But this is the end of the tutorial. We just show how Power BI can be used also to somehow do data science tasks, that is comparing how good it was our models. So yeah, maybe we just go back to the slides.
Yes, thank you, Ismail. That's very extensive walkthrough. I hope that was, as you're walking through this yourself, you can just kind of use this as a guide. And we don't have a ton of time left. Should we just quickly step through the knowledge check? I know some folks had to drop and they put their answers in the chat, but in the interest of time, let's maybe go through them super quickly. Let's do that. So we did have some knowledge check questions. And actually, just realized we didn't quite cover what classification, regression, and forecasting were. But in this case, if you are have access to historical data set that contains monthly expenses, and you want to generate predictions for expenses for the coming month, what type of machine learning model is needed? Maybe this is something that people could actually guess in right now. If you have an answer, put it in the chat, but I will reveal that this would basically be a forecasting model because you have that kind of revenue or expenses, in this case, month over month. All right, we had a second question here. Which feature in Microsoft Fabric should you use to review the results of MLflow's tracking through a user interface? All right, so this is a little bit tricky, but it's the MLflow's tracking. So think about that part. It actually, two of them actually fit into this, but if we're going to relate, well, experiment is probably the one that fits better, but actually on a model, you can also do a similar tracking right now. So both, actually, I would give an answer right for C as well. And then we have, I think this is the last question. If you want to log the accuracy of a model, which logging function should you use? This is a tricky one. Ismail, I don't know, did you walk through this in detail?
Yeah. When we were talking about all these models have ways that we can use to evaluate them. That's what I was mentioning to our metrics. So, well, the correct answer here is the metrics, because the parameters is what how we configure the model, and the artifacts sometimes are the things that we use with the model. So, yeah.
Exactly. So if you paid attention there, I clearly didn't, but if you did, then you got that one right. So with that, let's continue and cover, like one of the things that we wanted to call out is that we showed you the notebook experience. We spent a lot of time in the notebook, some time in the model and experiments and in the report as well. But just know that we have a lot of exciting Copilot experiences coming. And if you're not an experienced Python or notebook user, you can rely on Copilot as well to a certain degree, right? To get started, to learn how to use things and what type of code to write. We also showed you Data Wrangler and a lot of these like low code experiences. So that's really our goal, to make it easy and less intimidating to apply machine learning and do data science in Microsoft Fabric. But not only that, even data engineering and all of that. Data Wrangler is also for data engineers, right? It's not just a data science tool. So really, we're inclusive of all of that. So wanted to call this out, so stay tuned for Copilot in notebooks, in Power BI, and other Fabric experiences. And here are some links. We typed the entire link out, so you can actually take a screenshot or something and navigate to these links and to learn more. And with this, Ismail, I'll let you wrap up the session.
Okay, thank you. Okay, so we have, well, as you saw, we did a little bit of theory at the beginning. We understood how was the data science process, and we talked about Fabric and the capabilities it has to do data science. We also train models. We see this in practice with a long notebook-based workflow. And finally, we showed that we could integrate this easily with Power BI to serve these insights. So definitely that's the goal. We achieved everything. I was scared we wouldn't do it in 1 hour, but somehow we did.
Yeah.
Okay, so now it's time to call out for the upcoming things. Well, of course, if you want you then do this interactively with us, you can also take a look back at the full module and do a step by step of everything. Now, in the next slide, we will see that the next session in next week is going to be about how to administer Microsoft Fabric. So if this is the last session of our series, please join, especially if you care about this management part of it. That's what I know the less of Fabric, so I probably will be around. So
Yeah, definitely. That's going to be a super interesting one. There you go.
As I said, this is next Tuesday, October 24th. And again, we called you back to the Cloud Skills Challenge. If you follow all of these Learn modules at the end, well, you can compare and get these badges and brag about with your peers about all of this. And remember also that you can activate Fabric easily. If you don't have an access today, you can also create an access through your normal Microsoft 365 account. You go to this link, you follow the steps, and you get there. So that's
yes,
it.
Thank you.
Okay, thanks all. That was a great session.
Hey everybody,